Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at more chemical reactions. So the first thing we take a look at is a new type of reaction, double replacement reaction. Hopefully this name sounds familiar because in the previous chemquest we learned about single replacement reactions. Remember guys, in single replacement reactions we use these letters to symbolize the reaction. Remember you have a lone element which is symbolized by A, and it switches places with another ion in a compound which is symbolized by Bc. Then the element that was in the compound is now alone, and then A and C formed a compound together. Remember guys, the positive ions trade places in single replacement reactions. Double replacement reactions are very similar. Down below we find some double replacement reactions. Hopefully, after analyzing and taking a look at some of these reactions, you notice a similar pattern to what I wrote over here. Unlike single replacement reactions, double replacement reactions have two compounds involved in the reaction. So, we can use the name to help us remember that. Double replacement or double compounds, two compounds. So that's what you see over here. Instead of having a single compound in A and a single element in A and a single compound in BC, over here we have two compounds, AB and CD. Then, just like before, the positive ions, they end up trading places. So then AB and CD become CB and AD. So down below, we can use what we just talked about to remember the difference between single replacement reactions and double replacement reactions. Remember, single replacement reactions are involved with a single element and a single compound. Double replacement reactions, they have two compounds. So we can use that language to help us remember these definitions. Single replacement, single element, single compound. Double replacement reaction, we think double, we think two compounds. So, when we are completing the following reactions, following double replacement reactions, there are a few steps we need to follow, and they end up being the same as the single replacement. So we need to identify the charges, then the positive ions trade places, and then we crisscross to find a new compound. So I've got a few of them circled that I'm going to help you with, and then I'm going to want you to do C and E. So one thing I already did to make this go a little bit faster in the video is I already included the charges on all of my different ions. Remember, I used my periodic table and polyatomic ion list to do that. So when you are doing C and E, that's the first thing you need to do. Identify the charges using your periodic table. So, I know that the arrow is pointing to the reactant side. However, we can still figure out what this product is. We already know what one of these are. So what I like to do with the positive ions trade places is just like up here, I like to draw my arrows. It just helps me visualize it. So we know that this copper is going to switch places with the sodium, and the sodium is going to switch places with the copper. And that's because they are positive. So they already give us the reactant for CuNO3, so the copper binding to the nitrate, so then we need to include the one for Na and Cl, because those are the other reactants that are left. The copper and the nitrate have already been used. So now, remember guys, step 3 says to crisscross to find the new compound. So we know sodium has a positive 1 charge, chlorine has a negative 1 charge. We then crisscross, and we become NaCl. We do the same thing in part B. Remember, identify the charges. I already did that to save some time. Then the positive ions trade places. So the zinc has a positive 2. It's going to trade places with the aluminum. We look at the formula they already gave us, Zn and I2. So that means the zinc and the I were already used. So now we have left Al and SO4. So now when we combine those, we need to crisscross to find the new charges. So we have Al with a positive 3 charge. We have SO4 with a negative 2 charge. And then we crisscross. We bring the 3 to the right side of the sulfate, the 2 to the left side. That then becomes Al2, SO4, 3. The last one I want to do for you is D. So D is really similar to the ones that you're going to be solving in C and E. However, I'm going from products to reactants. You guys are going to be going from reactants to products. Makes a lot more sense. It's a little bit easier when you can just follow the arrows. So, the first thing we do is identify the charges. I already did that to save some time. We then find that the positive ions trade places. So that means Ba and Na, because they have the positive charges above them. We then need to create our new compounds. So up before, we had to figure out what they already used because they gave us one of the compounds. Down here, you need to make both. So we don't have to cross out anymore. So we know that Ba is going to be bound to calcium because they're trading places. Barium has a positive 2 charge. Chlorine has a negative 1. We then crisscross. Bring the 2 to the right side, the 1 to the left. Becomes BaCl2. We do the same thing for Na and SO4 because Na and Ba are trading places. So Na is going to be bound to SO4. Na has a positive 1 charge. SO4 has a minus 2. We then crisscross. We bring the 1 to the right side of the sulfate, the 2 to the left side of it. We then rewrite it. Na2, SO4. Cool. So then that's how we get our answers. Remember, don't forget to crisscross to find the new compounds. I want you to try to do what I did in A, B, and D for C and E. In question 3, I want to make this one a little bit easier. I want you to name the 2 products in the reaction in 2E. So after you get your answer in 2E, name those products. Okay. Number 4. Number 4 is a pretty important question. So we need to explain why when we mix the following reactants, no reaction occurs. So we know, based on charges, that sodium in both of these has a positive 1 charge. So that means the positive ions will trade places. So well, look, if the 2 sodiums trade places, then you get the same products. Nothing new is formed. Remember, guys, if nothing new is formed, then a chemical reaction doesn't occur. And that's what I say right here. This means no chemical reaction occurs because nothing new is formed. The next pieces of information, we have another type of reaction called combustion reactions. So combustion reactions end up being pretty easy because they tend to be the same every single time. In a combustion reaction, your reactants are always a hydrocarbon and oxygen. So down here, I kind of highlighted the C3H8. That's your hydrocarbon. It's exactly what it sounds like. Some amount of hydrogen combined to some amount of carbon. So it's always some amount of hydrogen with some amount of carbon. That's your hydrocarbon. It tells you what it is in the name. It has always been reacted with oxygen. Remember, guys, oxygen is diatomic. So that's why it appears as O2. It does not like to be alone in nature, so it will bind to itself. And then it also happens out that the products are the same. The products are always water, carbon dioxide, and energy. Remember that the energy it releases is in the form of heat. So when we're solving these problems, we're always going to have a hydrocarbon, it's always going to react with oxygen, and it's always going to release CO2, H2O, and heat energy. So when you're completing these reactions down below, you already know the answers, and now you just need to fill in the blanks. The next 2 reactions are synthesis and decomposition. So in a synthesis reaction, several reactants combine to make a single product. So that's what we see right here on this side of the table. We see H2 and O2 combine to form water. We see Na and Cl2 combining to form NaCl, which is salt. So then that's what I wrote for the letters. We have A plus B going to AB. During a composition reaction, one reactant decomposes into 2 or more products. So then that's what we see on the other side. On the other side, it's now water breaking up into H2 and O2. It's salt breaking up into Na and Cl2. So then that's what you see with the letters right here. It's AB breaking up into A plus B. I purposely used the same letters, and hopefully what you noticed already when I was talking about it is that synthesis and decomposition reactions are the exact opposite. So you can use this information to help you answer question 7. When you're answering question 8, So we need to kind of just read what it says. Remember, this will be helpful from the previous chemquest because it tells us sodium metal. So we know that Na, because sodium is the metal, is going to react with chlorine gas, which is just Cl2 because chlorine is a gas. And remember, it's Cl2 because it reminds us right here that chlorine is diatomic. Chlorine doesn't want to be alone when it reacts. So then when A plus B combines in... Oh yeah, that's exactly... So then when A plus B combines, what does it form? Oh, now we're on question 9. So question 9. So now we're on the kind of like the review part. So now you can use the information that we learned from the 4 other types of reactions and the single replacement reaction from the previous chemquest to identify the different reactions. Question 10. Question 10 is asking us to write a combustion reaction, so I'll help you guys get started. Remember, if we look at combustion reactions, it tells us right here exactly what happens. The hydrocarbon reacts with oxygen to form water, carbon dioxide, and energy. So we know that this is the hydrocarbon that we're using in this reaction, C3H6. It told us what it always reacts with, and it told us what it always forms. So then you would need to fill in the blanks. Next we have a decomposition reaction for calcium oxide. So first we need to figure out what calcium oxide is. So calcium oxide is calcium with a positive 2 charge combining with oxygen with a negative 2 charge. We then crisscross and it becomes CaO. Next we need to go back and look what a composition reaction is. A decomposition reaction. Decomposition reaction is when one reactant forms 2 products. So that's what we're going to see happen here. CaO is going to break up into 2 reactants. Oh, a little out of focus. There we go. Which 2 reactants is it going to break up into? Remember to check, are any of them diatomic? So now we are on some practice problems. So again, use the notes from this chemquest and the previous chemquest to try your best and answer these questions. Remember guys, if you have any questions, please circle them to bring them to class. Like always, I will try to end with a joke. So why did one banana stare at the other? Because it was appealing. I hope everyone has a wonderful day. I'll see you in class. Bye.